Hello students, hope you all are fine. In the previous lectures, we were discussing about the chapter electricity, in which we discussed and concluded that electric current depends upon what? Potential difference and resistance of a circuit. Now students, in many electrical appliances, we need two or more resistances. They can be connected in two ways. Either resistances can be connected in series or in parallel. In the previous lecture, we discussed about the resistance in series. Now in today's lecture, we are going to discuss the resistance in parallel. Now students, what is resistance in parallel? How they are connected? And what is their effect on the electric current and the electric potential or potential difference? That we will see in this lecture. When two or more resistors, right students, two or more, number can be many, are connected simultaneously between 2 points, to each other, then they are said to be connected in parallel combination. Right students, when two or more than two resistances or resistors are connected simultaneously, they are connected simultaneously between 2 points to each other, then they are said to be connected in parallel combination. They must be connected between the 2 points. Here the 2 points are X and Y. Now students, here I have drawn a diagram in which I have shown 3 resistors, voltmeter. Now I will connect all this with a battery. When I will connect it with battery, the potential difference is established and the current will start flowing. In resistance in series, we discussed that the electric current between all the resistors, like we discussed this, when the resistors were connected in series and we applied the electric current between all these resistors remains the same. But the opposite is in the case of the resistance in parallel. When the electric current will start flowing, it will flow towards this direction, towards this resistor and also towards this resistors. So this electric current will be different. In resistor 1, the electric current will be 1, in 2 and in 3. In all the resistors, the electric current will be different. Now the total electric current will remain the same. It will be the sum of the electric current in resistor number 1, in 2 and in 3. Like this, the total electric current is equal to the electric current in the first resistor plus electric current in the second resistor plus electric current in the third resistor. Now students, we know according to the Ohm's law, electric current is equal to potential difference upon resistance. This is Rp is the total resistance. Rp is equal to total resistance, which is equivalent to R1 plus R2 plus R3. Now students, we have talked about the electric current which is different in all the resistors, but what about the potential difference? Students, the potential difference will remain the same. Why the potential difference will remain the same? Because here the starting and the end point of all the resistors is same. Right student? Starting point is X and the end point is Y for all the resistors. When the starting and end point is same, because potential difference we measured between the starting and the end point, then the potential difference is same. So the potential difference across all the resistors R1, R2, R3 will be same, because the 2 points starting and the end points are same for all the resistors. So the potential difference will remain the same and the current across all the resistance will be different. So by applying Ohm's law, we know that current is equal to potential difference upon Rp, means total resistance. So we can also elaborate. We see in the first resistance, second and for the third. By this we can apply, we know I is equal to I1, I2 plus I3. I is equal to V upon Rp. Right, students? I1 is equal to V upon R1. I2 is equal to V upon R2 and I3 is equal to this. By taking V common, we get 1 upon Rp is equal to 1 upon R1, 1 upon R2, 1 upon R3. What does it mean? The reciprocal of the equivalent resistance of a group. This is equivalent resistance of a group. The reciprocal of resistances joined in a parallel is equal to the sum of the reciprocal of the individual resistances. The reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of reciprocal of the individual resistances. So, we get this formula by which we can solve many numericals, because our purpose is to calculate the total resistance. When it was joined in series, now it is joined in parallel, and we want to know about the total resistance, the reciprocal of the equivalent resistance of a group of resistance in parallel is equal to the sum of this reciprocal of the individual resistances. So, this is all about the resistances when they are joined in parallel. Hope you must have understood it. There is one difference, main difference between the resistance in series and resistance in parallel, that is, when we join the resistors in series, the electric current remains the same, but the potential difference is different, because for all the resistors the starting and the end point is different. So, the potential difference is different for all the resistors. But when we join the resistors in parallel, resistance in parallel, then the electric current is different for all the resistors, but the potential difference remains the same, because the starting and the end point of all the resistors remain the same. So, that's all for today's lecture and resistance in parallel. Hope you must have understood. Till next lecture, take care. Have a nice day. Thank you.